Hi folks, let's go for the next problem in continuation with what we did last time. We had done the 7th sub question, now we are taking up the 8th sub question. It's saying that g of x is a product between x and root of 1 minus x. Let's go on to solve this and see how it comes. As we do all the time, we'll take the first derivative, we'll take the second derivative, and always make the first derivative equal to 0 to get the critical points, and then check out whether it's a maximum point or minimum point by looking at the second derivative. So that's going to be our work. Let's see now how we can do it. Let's get the first derivative. So for getting the first derivative, treat this as a product, x and root of 1 over x. Root of 1 minus x, so those are going to be a product. So in order to get the derivative, first we write x as it is, get the derivative of root of 1 over x. So root of 1 over x, we know root of a function is 1 by 2 root of that function. So the derivative of root of 1 minus x is 1 over 2 root of 1 minus x, and then into, that's chain rule, and then into derivative of 1 minus x. Derivative of 1 minus x is minus 1, because for 1 minus x, if you are taking the derivative for 1 is 0 because it's a constant, and derivative for x we know is 1, so negative x is going to be negative 1. So overall its derivative is going to be negative 1. So that's it. So the derivative of this function is negative 1. Let's check now how we can work out with that. Yeah, so we have here we'll have to write derivative of negative x as minus 1, that we have to account for, and after that is over, we can take keep root of 1 minus x as it is, derivative of x is 1. Now let's solve this. This is negative x over 2 minus root of 2 times root of 1 minus x plus root of 1 minus x. So we can maybe solve it. So we can equalize over here, and then we can get minus x plus 2 1 minus x, because you are equalizing with 2 times 1 minus root of 1 minus x. You are equalizing with that. So as a result, you will be getting root of 1 minus x. Root of 1 minus x is 1 minus x, and in the denominator you are getting 2 times root of 1 minus x. Yeah, so that is going to be our simplification of this whole thing. If you want, we can work out further. Minus x plus 2 minus 2x minus 3x plus 2, that is our f dash x. Now having got f dash x, obviously we know that we have to be getting f double dash x. So let's go for f double dash x and see how it comes. That is your second derivative. Let's look at the second derivative. So for the second derivative, obviously this is going to be a u over v function, and you are going to apply the quotients to get the answer. So let's see how the quotient is going to work. It is going to be 2 over 1 minus root x, let it be as it is. Let's find the derivative of the numerator, which is going to be only minus 3, because derivative of minus 3x is minus 3, and 2 is a constant function, doesn't have any derivative, so overall the derivative is only minus 3. Then minus, you have minus 3x plus 2 as it is, and derivative of 2 times root of 1 minus x is going to be 2. Root of 1 minus x, as we saw earlier, is 2 over root of 1 minus x and minus 1. That is accounting for the base 1 minus x. So that way. So maybe this and this can get cancelled, these two, and minus into minus can become plus. And let's see how we can simplify. It's minus 6 times root of 1 minus x plus minus 3x plus 2 over 1 minus root of 1 minus x. You can simplify this and equalize and all that, but actually it's not necessary, because we have to only substitute and get the answer. So there's no harm if you simplify, but not necessary, because in the exam, suppose if you are running short of time, these are the places where you can save the time and do other work. right? So let's leave it for the time being, and let's go on for the critical point and find out what is the critical point. Let f dash x be equal to 0. Then in that case we are actually getting minus 3x plus 2 over 2 times root of 1 minus x, which is 0. So we have this going on the other side, so that becomes 0, and then you are left with minus 3x plus 2, which is 0, which we solve further. We take the 3x on the other side, so you get 3x becoming 2 and x becoming 2 over 3. So your critical point works out as 2 over 3. So we are only done with the critical point. Our next is to find out whether this critical point is a maxima point or a minima point. So let's find that. So in order to find whether it's a maxima point or minima point, as usual we are using the second derivative, that is second derivative at 2 over 3. Let's find out. So when we substitute it, it is minus 6 root of 1 minus 2 over 3 plus minus 3 times 2 over 3 plus 2 over 1 minus 2 over 3. Now this is quite a simple work. Why? Because if you simplify, this entire thing is becoming 0 because the numerator is becoming 0. So this part you need not take care at all, it is becoming 0. Only be bothered about this part. And this part also, when you look at it, it is like negative 6, and when you simplify it, it is 3 minus 2. So I think it will be root of 1 over 3. Anyhow, it is very clear that it's a negative quantity. So we can say that therefore 2 over 3 is a maxima point. Okay, now having got it as a maxima point, let's find the maximum value, that is f at 2 over 3. Let's find the maxima value, and the maxima value is going to be 2 over 3 times 1 minus 2 over 3. So let's work that out. 2 over 3, when we solve this, 3 minus 2 over 3, which is 2 over 3 times 1 over root 3, or rather it is going to be 2 over 3 root 3. That's going to be your maximum value. You know that there is a maximum which is happening at 2 over 3, and we are bothered to find out what's the value, and that value comes out as 2 over 3 root 3. Now sometimes we are not very happy to keep the root in the denominator. Then in that case you should get it rationalized and get the rationalized value for that function. This is how that problem is all about, to decide whether whether there is a maximum or minima point and which is that point. So this is how we are going to decide. So that's all for this video. We have so many problems in the exercise. So we are meeting again with the next problem in the next video. Thank you.